Hi everyone, this is Dr. Wright. Welcome to your supplemental lecture related to the Scare You to Death Retirement Calculator. Please don't fear, it's not really intended to scare you to death, but it is meant to be a little bit of a wake-up call and to serve as some incentive to try to get you saving for your retirement early. As we talked about in class, and I do want to reiterate that you should have already seen this in class, so therefore this is a supplemental lecture and I'm going to move quickly. As we talked about in class, the objective of this spreadsheet is to help you know what percentage of your annual income you need to sock away every year in your retirement account in order to meet your financial goals and retire comfortably. Now, obviously, our first and foremost objective is to learn Excel. That's the purpose of the class, but I'm hoping that we can learn Excel by creating useful spreadsheets, things that will actually benefit you throughout your lives and your careers. So this is an important question. What percentage of your income do you need to put away in a retirement account in order to retire when you want to and with sufficient annual income in retirement? Well, in order to accomplish this, let's go ahead and review what the inputs are going to be to our document here. You can see the first input right here is what our current annual income is. And again, anything in yellow, all of these things, those are user inputs. So you have to manually type something in. Anything in green, these are going to be outputs, and we'll talk about the blue box in a bit. And this is all of our calculation down here. So these are all the inputs, all the yellow. First off, current annual income. You need to also put into the document what you think your annual average raises will be. Obviously, you need to know your current age, at what age you think you'll retire, and when you think you'll die. I know that's a bit of a morbid topic. That's why we're not calling it your death age. We're calling it your expiration age. Also, if you have any beginning retirement savings, let's take that into account. You need to know how much you think you'll earn in terms of your rate of return on your investments. You need to take into consideration inflation. And then these last couple might need a bit of explanation. What I'm asking right here is, if you were to retire right now, what percentage of your income would you need in order to be comfortable? I have a default of 75%. Most people agree that you won't need 100% of your salary in order to retire comfortably. If you're asking why that is, it's because some of the major expenses that you have, specifically your house payment, should be gone by the time you retire. We hope that your house is paid off when you go into retirement. And also, you might have other streams of income. In fact, you should have other streams of income, whether it's rental properties or Social Security. We're assuming that there's some other streams of income coming to you. So what this is saying is, if I make $120,000 right now, I need 75% of that in order to be comfortable. Therefore, I would need $90,000 a year right now in order to retire comfortably. Well, our big question is, what percentage of our income do we need to contribute to our retirement account in order to make that happen? But there's one other important input variable to talk about. That is, how much money do you want to have left over when you pass away? I'm starting out with $500,000. Now, you might be saying to yourself that that seems like a relatively unimportant number since you, quote, can't take it with you. I agree, you can't take it with you, but I also am of the opinion that you're not very good at guessing when you're going to die. And so think of this little fund right here, think of this number as your contingency plan. What if I live longer than I anticipate? This is what's going to tide you over. So let's dive right into it here. Let me show you what we've got. What I do in the spreadsheet is I just figure out every year what's the cash in and what's the cash out. Now, something that's really, so you can see age 36, I have a salary of $120,000. I'm starting out with $60,000 in my retirement savings. I'm going to contribute 10% of my salary to my retirement account this year. So I'm going to contribute 10% of that, which is $12,000. Don't have any withdrawals because I'm not retired yet. Now, what return are we going to earn? Well, keep in mind, we're assuming that all deposits occur at the end of the year. So we won't earn any return on that $12,000 this year. We'll only earn the return on our beginning retirement savings. So we're going to get 7.5% of that number, which is $4,500. So what will my ending retirement savings be? Well, it'll be $60,000 plus the $12,000 plus the return of $4,500 to give me an ending retirement savings of $76,500. As we scroll down, you can see at the end of this year, I turn 68, which means I retire, no longer earning a salary. Now I'm starting to withdraw money. And I'm still earning a return on my nest egg here, but you can see the nest egg is slowly declining. I'm eventually going to reach age 95, at which point I expire. You can see there are no more years after that. But you can also see I've run out of money several years before 95. So clearly, what I've got going on here isn't going to cut it. I'm going to have to change some things, and we'll talk about that. But before we do it, let's figure out how we can actually make this table happen. Now, I need to show you a couple of cool features about the table. First off, if I change my inputs, notice how things are going to happen. For instance, what if I make my current age 65? Well, you can see that first year my age became 65. What if I say I'm now going to retire at age 67 and I'm only going to live until age 72? Well, you can see first year 65, I'm retired at the end of my 66th year when I turned 67. But look, there's nothing down here. It's cut off. The table actually stops generating numbers once it reaches the expiration age. So there's some nifty tricks that I'm going to have to show you as we go through this. Let's dive right into it. So I'm going to bring up another spreadsheet. So there's a new spreadsheet for us. I'm going to zoom it in a little bit so you can see it a little bit better. And I'm hitting some hotkeys here. Don't worry too much about the hotkeys, although very useful and can make things go more quickly for you. I'm going to just copy and paste quite a bit of this, if you don't mind. And in order to do that, I'm just going to go like so, using my hotkeys again. I'm going to spread that out just a little bit so we can see the numbers. Spread that out just a little bit so we can see the numbers. And then what I'm going to do is I'm going to actually fill in everything. Actually, let's not fill it in quite yet. Let's create the spreadsheet and then we'll format it. So first thing we want to do is we want to create the age variable. I think it's obvious that the first year right here needs to be the age that we currently are. And I think I want to send this back. If you don't mind, I'm going to revert everything back to what I originally had. And so there's my original inputs. I'll go ahead and copy all this again because I'm going to have to copy and repaste. Sorry about that. Don't mean to be redundant. And let me zoom us in again real quickly there. Again, forgive the hotkeys. All right, so let's get this beginning age variable. So all I'm going to do is I'm just going to link it up to that current age. So I'm just going to hit the equal sign, and I'm going to go ahead and click on that current age, and there it is. It gives me an age of 36. And so then from there, what we want to do is we want to show the right age in the next year, but if we reach expiration age, we don't want to see anything. So in other words, you know, as long as this cell right here, which the next year would be 37, we definitely want to see that. But what about when we get way down here and we get to 96? Well, we don't want to see 96 because our expiration age is 95. This is also a good point where we can freeze the frame. Let me show you what I mean by freezing the frame. If you'll notice over here, if I scroll down, you can see that while I'm scrolling, everything up here stays constant. So I've frozen the frame so that we can see the inputs and the row labels as we click through the table. So let's do that over here. It's very easy to do. Highlight that entire row. I come over here to the view, freeze panes, and I freeze the panes, and now you can see when I page down, it's going to keep all the inputs there, although I recognize that I did it on the wrong row. So let me unfreeze those panes and go one row lower and freeze the panes. And there we have it. Now we can see the row labels as well, which is really important. Okay, so how are we going to make it so that this will show me the year as long as we haven't gone past the expiration age? Well, this is how we're going to do it. I'm going to use an if-then statement that says, if this year right above is nothing, and the way that you do nothing in Excel is just 2 quotation marks. If the previous year is nothing, then that means we're already past the expiration age and we don't want to see anything here. Remember in Excel, the nomenclature is if, parenth, give it the logical criterion, comma, tell it what to do if the criterion is met, comma, tell it what to do if the criterion is not met. So what we've said is if the previous year is nothing, now we need to tell it what to do if that's true. If that's true, then we don't want anything here. Double quotation marks. If the previous year is nothing, give me nothing. However, now that we've given it the second quotation mark, we need to tell Excel what to do if that first criterion is not met. So if the first criterion is not met, in other words, if there is a year, then what we want to do is another if-then statement. We want to say, well, if you take that year and you add 1 to it, if that is less than or equal to the expiration age, then let's just take that previous year and add 1. In other words, what we've said is, if there's a year here, then add 1 to it. And if that is less than or equal to the expiration age, then show it to me. But if it's not less than or equal to the expiration age, in other words, if this criterion is not met, then what do we want it to do? Well, we don't want to see anything. And that should work. Now, very important, lock in any of these variables coming from the input section. B7, that's an input variable. Lock it in with the $sign in front of the B and the 7. That's very important, because if you don't do that, if you don't lock it in, let me show you what's going to happen. See how our year stopped at 38 and now all of a sudden there's no year here? Well, here's why. When we took this formula and we drug it down, or when we took this formula and drug it down, look at what happened. Do you see that B7 right there? That B7 turned into a B10. So instead of referring to the expiration age, it's now referring to the assumed inflation rate, which is not what we want. So you got to lock in that B7. Lock it in. Pull it down. Look, there's no harm in taking it far beyond where you actually need it. But let's do a little spot check and make sure it works. We can see it stopping at 95. Let's put in 97, and it looks like it works. Good. Okay, now the salary. Well, obviously our initial salary is going to be $120,000. But after that, what we want to do is we want to grow it at our assumed annual raise. So what we're going to do is this, is we're going to say, okay, if that year equals nothing, then that means obviously we're outside of the expiration age and we don't want a salary. So if the year equals nothing, give me nothing. However, if there is a year, we have to do another nested if-then statement. So if there is a year, then what we want to say is if that year is less than the retirement age. If the year is less than the retirement age, then we want the salary, but we want it adjusted for how many years of raises we've received. So take the salary, multiply it by 1 plus the annual expected raise, but we have to raise that to however many years out we are. So we have to raise the 1 plus the expected raise. Well, in this case, we're only 1 year out, but don't type in the number 1. Do it this way. Take B17 minus B16 and lock in the B16. Do you see what you've done? You've taken B17 minus B16, which gives you 1. But what's going to happen is if you drag this formula down 1 cell, that's going to become B18 minus B16, which is 2. In other words, if you had manually typed in 1, just raise it to the 1, you would have to manually type that in all the way down. The way that we're doing it, you can just do this formula once and drag it. And that, frankly, is awesome. Again, lock in anything in the input column there. So the B6, B3, B4. Great, lock it in. Not sure exactly what mistake I made. I must have forgotten a parenth. And then double click it down and we're going to format it. And I personally like to center everything. Okay, now we made a mistake and it's okay. I mean, this happens in Excel and I know exactly what I did wrong. See how we got to 68 and it's saying false? That's because I forgot to give it an argument. Maybe you spotted that as I was doing it. But if you look right here in this nested if-then statement, what we said is, okay, if the year is less than the retirement age, then yeah, calculate what our salary is going to be. But we never told it what to do if the year was past the retirement age. So if the year is past the retirement age, we don't want any salary because we will have retired. So that's the fix that I needed to do. So let's enter it, let's fix it, then let's make sure we understand the formula. You can see it's right. So let's dissect this formula. Okay, up here at the top now. If the year, or my age, is nothing, give me nothing. However, if there is an age, then if that age is less than the retirement age, then take the salary and grow it by however many years out we are. However, if that age is greater than the retirement age, give me 0, and then I'm closing the parentheses, and there we have it. Okay. All right, beginning retirement savings. Well, in the initial year, right, the beginning retirement savings comes straight from the input table. In later years, the beginning retirement savings is going to be the ending retirement savings from the previous year. We don't quite have that yet, so why don't we complete this first line, then we'll do all these formulas and run them down. Okay, so next what we want to figure out is what the deposit's going to be every year. Well, remember, the deposit's just going to be whatever this percentage right here is. That's the percentage of our income we're going to contribute, and we're going to multiply that by our salary. However, that's only going to happen if there is a salary, so we're going to do this. If the age equals nothing, then that means there's not going to be a deposit. That means we're past the expiration age. Otherwise, take the salary, multiply it by our percentage contribution. It's a very simple formula. Make sure you lock in everything up there in the input table, which would be the B13. And that should be something that we'll be able to just roll down, but let's leave it for now. All right, what's our withdrawal going to be? This is going to be one of the more challenging formulas. What we have to do is we're going to have to say we're only going to have withdrawals after we've retired. So what we're going to do is this. We're going to say, well, if the age equals nothing, give me nothing, because that means we're past the expiration age. However, if there is an age, then if that age is greater than or equal to the retirement age, then we're going to withdraw. But how much are we going to withdraw? Well, this is how much we would withdraw today right here, but we need to grow that by the inflation rate. So we're going to take that number and multiply it by 1 plus the inflation rate, again raised to however many years out we are. Well, how many years out are we going to be? We're going to use the same trick that we used before, and I'll explain this to you. But let me finish the if-then statement. So where are we? If the age equals nothing, give me nothing. Otherwise, if the age is greater than the retirement age, then give me this withdrawal amount. However, if the age is not greater than the retirement age, then give me 0. Close up the parent on it. Okay. Lock in everything in the input table, which would be the B6 and the B12 and the B10. Now notice something you may not have caught, and I'll explain this to you in just a second. Right here, this is the exponent. So this is $90,000 times 1 plus the inflation rate raised to B16 minus B16. Now you might be thinking that's stupid. Well, the reason we did that and we locked in, notice we locked in the second B16 but not the first one. When I pull this formula down, when I do that, that first B16 is going to turn into a B17. And when it does that, it's going to be 37 minus 36, which will be 1, which is exactly what we'll want here, because we'll be 1 year farther out, and so we're going to want to grow this number by 2%. So what we'll do is we'll do this whole row, we'll drag it down, and I'll make sure you understand all the formulas. What's our return going to be? Well, this is an easy formula, but you have to think about it for a second. Our return is going to be our expected annual rate of return times whatever money we have in the retirement account. Well, that's going to be the beginning retirement savings, but not the deposit, because we're assuming that deposits are made at the end of the year. Okay, now we could make some fancier assumptions, but that's just going to simplify it. We are going to assume, however, the withdrawals happen at the beginning of the year. So to get the return, what we're going to do is this. We're going to say if my age equals nothing, give me nothing. Otherwise, take the beginning retirement savings plus any withdrawals, okay, and it's going to be okay because we're going to make those withdrawals negative. We'll go back in and make those negatives. So take the beginning retirement savings times the plus the withdrawals, which are again going to be negative numbers, and multiply that by your assumed rate of return. Okay, and I forgot to give it the last argument. Lock in anything in the input table, B9. Okay, so there's your formula. If the year equals, or if my age equals nothing, give me nothing. Otherwise, take the beginning savings and the withdrawals, which again are going to be a negative number. So that's going to be the net of your beginning savings and your withdrawals, and multiply it by your average annual return. So then what's the ending going to be? Well, the ending is just going to be, if my age equals nothing, give me nothing. Otherwise, give me the beginning retirement savings plus deposits plus my withdrawals, which again are going to be negatives, plus the return, close the parenth. The ending age is very simple, right? We're just going to say, if that age equals nothing, give me nothing. Otherwise, give me the age plus 1. Close it up. Now, let's see if we can drag these down and make it work. Beginning retirement savings in the second year is no longer going to be the $60,000. It's just going to be this number right here, but only if we're still alive. So if this year equals nothing, give me nothing. Otherwise, give me this number, and that's it. And you can shoot that all the way down. Deposit. That formula right there can actually be shot down. I'm going to drag it down once. Let's look at it. So what it says is, if the year equals nothing, give me nothing. Otherwise, take the salary, C17, and multiply it by my percentage contribution, B13. That formula is golden. Shoot it on down the line. Withdrawals. We're going to drag it down once and see if we can shoot it all the way down. If the year is nothing, or if my age is nothing, then that means we're past the expiration age, then there's no withdrawals. However, if there is an age, if it's greater than or equal to the retirement age, then give me this retirement money, annual retirement money, adjusted for inflation, which is 1 plus inflation raised 2. Remember how we did this. Take that 90,000, multiply it by 1 plus the inflation rate, but you have to consider how many years out you are. How many years out would we be? Well, it would be this year minus this year. So B17 minus B16. Notice B16 is locked in. That formula is beautiful. Send it on down the line. The return formula is golden. Send it on down the line. And the ending retirement savings, that formula should also be fine. Send it on down the line. And the ending age should be fine. Send it on down the line. Let's format this just a little bit. Let's center everything. And let's also do this. Let's turn all of these into dollar figures. So we'll just right click, paste special, and we'll just do the formats. And it looks like that. Okay. Now let's look at what we've got going on here. First off, I did forget to do one thing, which is why this is looking so beautiful. I forgot to turn the withdrawals negative. Remember, I want to have positive cash flows as positive, negative cash flows as negative. So right here, back in this withdrawal formula, I'm going to take this B6, which is, or the B12, which is 90,000, and I'm going to put a negative in front of that, and that's going to make a big difference. So I put a negative in front of the B12. Send that down the line, and you can see things change. All right, let's scroll down and see if our spreadsheet is working here. Okay, how will we know if it's working? Well, first off, you can see that at age 67, we have a salary, we make a contribution, we hit age 68, we no longer have a salary, now we're withdrawing. So that tells me the spreadsheet's working. We get to age 95, everything stops. So everything looks good. It's passing my sanity check. The salary looks like it's going up by 2%. That number passes my sanity check, that our first withdrawal will be $169,000 at the age of 68. If we're wanting $90,000 right now, and we're not going to withdraw for 32 years at an inflation rate of 2%, that number right there is reasonable, $169,000. So this all looks good. Let's format it, and then let me show you one last trick. Okay. Now, I personally like the black background. Now you don't have to get all picky with it here. But what you can do is this, right? You can fill all this in black and all this in black. That's easy to do. That's not hard. Then what you can do is you can actually do this too. You could fill all this in black. I hope I don't mess anybody up by doing this. But watch what I'm going to do. I'm just going to fill this all in black, and then I'm going to go back in and do some conditional formatting. And here's the conditional formatting. I'm going to highlight all of this way down here, way past where we needed it. You know, all the way out to where we could be 120 years old. You never know how long you're going to live. Right? I'm going to do conditional formatting. I'm going to put in a new rule. So do you see I'm up here? I'm on the Home tab, conditional formatting, new rule. I'm going to format only cells that contain no blanks. Right there. Format only cells that contain no blanks. How I'm going to format it? I'm not going to have any fill. I'll put a black border around it, and that's all I need. Click OK, and what you're going to see is that any cells that actually have content are now going to have no fill, black border, so it looks sharp. And the cool thing about this conditional formatting is you change any of your inputs. Watch this. What if I work till what if I'm 65? I'm going to retire at 67, and I'm going to die at 70. You can see there it is. Conditional formatting takes care of all of it for us. Let me reset the inputs and let me just point out. You're not going to make it. If you're 36, you have $60,000 of savings, you're going to work till you're 68, and you're going to die at age 95. And if you want $90,000 in today's dollars per year, and if you're going to contribute 10% of your income every year to your retirement account, and if you're assuming you're going to get a raise of 2% every year, and you're assuming inflation of 2% every year, you're not going to get there. You're going to run out of money. Specifically, you're going to run out of money when you hit age 92. You're not going to make it to 93. So something's got to change. Well, what I really want you to see from this assignment is there's only a few things you can control. You can't control your income. You can't control your raise, or at least not directly. You certainly can't control how old you are. Now here's one you can control. You can control at what age you're going to retire. Can't control when you die. Can't control how much you have right now. Can kind of control this, but certainly can't guarantee it. Have no control over inflation. You can control this. How much money do I need during retirement? And you can control how much you're going to contribute. Well, look, this makes a big difference. You're going to retire at 68, you're going to retire at 70. If you retire at 70, you're golden. If you retire at 70, you're going to have plenty of money when you pass away. However, most people don't want to do that. Most people don't want to work longer in order to be comfortable. Well, you could just try to get by on less. Maybe I don't need 75%. Maybe I only need 65%. Great. You're golden. You made it. However, that's also a sacrifice most people aren't really excited about making. So what's the one thing that you really can control and that's not going to hurt your retirement? Well, it's the percentage of your income that you contribute to your retirement account right now and while you're working. So maybe instead of 10%, you contribute 12%. Well, now you can see you make it. If you contribute 12% of your income, ceteris paribus, leaving the rest of these inputs the same, you're going to make it. So what I want to figure out is I want to figure out the exact percentage of my income that's going to leave me with at least $500,000. And so in order to do this, I'm going to leverage upon what's called the solver function. If you go to the data tab up here at the top, data tab over here on the right, under the analysis section, there's the solver. And what I'm going to do is I want to solve for that, the surplus or the deficit, which I guess I didn't really explain to you. In fact, I better back out of that and show you how I did these two things right here. So our goal is to have $500,000 at retirement. That's our contingency fund in case we live longer than we think we're going to. Well, I want to see what we're actually projecting we will have. In order to do that, I'm going to do a VLOOKUP. So VLOOKUP, and what am I looking up? Well, I'm looking up this age. And where am I looking it up? Well, I'm looking it up in this table and go all the way to the bottom. And specifically, what column do I want? I want to know the ending retirement savings. So what column is that? Well, 1, 2, 3, 4, 5, 6, 7. That's the 7th column. So what this function right here does, this VLOOKUP, is it's going to take the number in B795 and it's going to go find it in this column, the beginning age. And when it finds it, it's going to spit out the number in the 7th column related to that row. So you can see what it does is this, is it literally comes to this table and it looks for the age 95. And as soon as it finds it, it comes over to the 7th column and it grabs that number. Well, how much of a surplus or a deficit is that? Well, I'm just going to take the projected actual savings, which is a negative, subtract out what we wanted to have, and that tells me my deficit. Well, I want to know what percentage contribution makes that deficit 0. In other words, what percentage contribution to my retirement account every year gets me exactly $500,000. Now, look, there's multiple ways to do this. If you want to do it a different way, that's totally cool with Dr. Wright. I'm going to do it my way. The way I do it is data solver, and I'm solving for that target cell, and I want it to be 0. And the way I'm going to get there is by changing that cell. So again, that's the target cell, surplus or deficit. We want it to equal 0. By changing the percentage of our annual income that we contribute. Going to hit OK, and it's going to solve it for us. And you can see that the solution is 11.2%. Probably, if we give it another decimal point, it's not exactly 11. So it's 11.202%. So if you contribute 11.202%, you're going to see that down here at the end, you're going to have ending retirement savings of, sorry, I got to scroll up here. Ending retirement savings of $500,000. So, in short, in order for me to actually achieve this goal, in order for me to have the equivalent of $90,000 worth of retirement income from my retirement account, assuming these inputs and assumptions are okay, I need to contribute 11.2% of my salary to my retirement account. So I plug that number in there, 11.202. Anything I can do on top of that just makes it look even better. So if I can contribute 12%, then I should easily meet my objectives. So I call it the Scare You to Death Retirement Calculator, but in reality it's just the help you understand how important it is to start saving a significant percentage of your income so that you'll have adequate funds at retirement. I hope this helps. Feel free to rewatch the video or any sections that you didn't follow, and you can always contact me via email or come see me during office hours.